Hello, Algebra 2. We're in Chapter 7, Section 2. This is page 3 of the notes. And we have this problem involving exponential decay. Your television set, well, it cost $1,200. That's a nice TV. The value, it decreases by 21% every year. Write an exponential decay model, giving the television's value, y, which is in dollars, after 2 years. Estimate the value after 2 years, graph the model, use the graph to estimate when the value of the television will be $300. Good times. One part of this is actually totally insane. It says use the graph to estimate. The graph's nice to make and all, but you're not going to be able to actually use the graph to estimate it. Or maybe your graphing skills are much, much better than mine. But here we go. So the initial amount is A equals, well, the television cost $1,200 originally. And the percent decreases R equals, it's going down 21%, so 0.21. Remember, none of this business about using percents. You use the decimal version of the percent. So the model is y equals A times 1 minus R to the t. Totally an important general formula right there. We saw the same thing last time with 1 plus R to the t. Now for this one, 1 minus R to the t. Alright, so throw some numbers in for A and R. Easy enough to do. 1,200 times 1 minus 0.21 to the t. And then it says simplify. There's not much to simplify here, really. It's just 1,200 times 0.79 to the t. There we go. That's the exponential decay formula. And says when t is 2, the value is, and you let t be 2. So you throw that into a calculator. You don't do that kind of business by hand. $748.92. Maybe a little dollar sign in front to make it look cute. That's the answer to A. Now, let's move on to part B. Boom. The graph passes through the point 0, well, if you put 0 into that equation we wrote, it's 0, 1,200. Make that graph. That's spot pretty easily on the graph. 0, 1,200. Doop. And 1, 948-ish. 1, 948. Ooh, I don't know. That might be 947. There. Alright. It says it has the blank as its asymptote. Now, the asymptote, because this was not moved up or down at all, the asymptote is still on the axis. The fact that we're starting at 1,200 doesn't have anything to do with anything. So, normally it would be the x-axis, but this time the independent variable is called t for time. So it's the t-axis. And it says plot a few other points, then draw a smooth curve through the points. Okay, well, you know what? Zoom. Just plot a curve. Boom. Alright. Part C says using the graph, you can estimate that the value of the television will be $300 after about. Okay, now, no reasonable person would think that using a graph is the solution to this problem. So, really, boom. If you think using a graph is the solution, then I think I just called you unreasonable. I'm sorry about that. That was not intentional. But you can estimate. See that? Maybe a little capital Y. Boom. $300 after about, just use guess and check, right? You go back to the equation above. I can't get that equation back on here at the same time, but the equation was y equals 1,200 times 0.79 to the t. And really, you want to be guessing and checking for t values. Figure out about how big t needs to be for it to be about 300. And to the nearest whole number, I think it ends up being about 6 years. But really, guessing and checking is a better method than trying to make sense of what's going on with the graph, because it's not making a lot of sense to use the graph for this kind of detailed work when the scale is as ridiculously small as it is in the graph. But moving on, we have checkpoint 3. which is rework that same example with a 12% decrease every year. Okay, well, there's value here because we know certain pieces of information. First of all, the initial value, 1200, and we know the rate of decrease is 0.12. And the reason why that's important is because we can use that general formula, y equals a times 1 minus r to the t. So y equals 1200 times 1 minus 0.12 to the t. So y equals 1200 times 0.88 to the t. You might be curious what's going on with this 0.88 business. First of all, you might be curious why you can't draw an 8, so I'll try to fix that for you. Yeah. The real thing going on is that this 0.88, I'm going to underline it in blue here, that's the percent value your TV is keeping every year. So you're given information about how much it's going down, but that doesn't really help you too much. You actually can only act on the percent of value that it's keeping between the years. And so that's what the 0.88 means. And if what I just said doesn't make a lot of sense, it's not that big a deal. You can just kind of work your way out using that formula every time. And then, we plot some points. We have the point 0, 1200. And if you plug in 1, you get 1, like 1056-ish, I think. So, boom. The t-axis is still the asymptote. That can sometimes seem strange because we're dealing with such a big number that it's all the way down at 0, but it is. And then, if you're so moved, you can draw an exponential decay graph. You can plot some of the points if you want. If it looks like you missed your point, you can just make your points slightly larger. But that's generally the gist of it. And then I think, if you wanted to figure out when it was worth about $300, again, guessing and checking is really a better opportunity here. Actually, I'm going to teach you the right way of doing it, but you're going to have to wait until after spring break to learn. 11 years-ish. That's the end of page 3's notes. That is the end of the notes for the section. Thank you for watching.